Great morning, mini mathematicians. So happy you could be here today. We're going to be working on 6.0C review, triangles and angles, and it is a handout. You will need a protractor because we're going to be measuring angles. So please pause the video for 2 to 3 minutes to finish writing down your lesson purpose in your notebook and pass out the handout for the lesson. Thank you. Please pause the video for 2 to 3 minutes. Okay, so let's review a little bit about angles. So we're going to be using a protractor, and your protractor hopefully has centimeters on here so that we can be measuring our lengths of our triangles. So really quick, let's review what we've gone over in your vocabulary review and last lesson when we learned how to use a protractor. So if you have an angle, we always have a vertex of an angle. And if you have an angle like this, it's called that's right, it's called a straight angle. And that's going to measure 180 degrees. If I told you something was an acute angle, oh, it's so acute and tiny, that's going to be less than 90 degrees. So remember, 90 degrees are also called right angles. So maybe we should talk about what a right angle is first. A right angle is kind of like the side of a square or a rectangle. They're 90 degrees. So you could say, if you're cold, go into the corner of the room. It's about 90 degrees. So we can, laugh. 90 degrees. So an acute angle is going to be less than 90 degrees. So squishy L, 90 degrees. Maybe I have the bottom of the angle, my vertex. I'm going to just make an angle that's less than 90 degrees. And the other type of angle we talked about is going to be greater than 90 degrees. And those were called, do you remember what those were called? That's right, that's called an obtuse angle. So maybe I make my vertex, and I'm just going to make that greater than 90 degrees. But notice it's still less than 180 degrees, which is my straight angle. So those are ways that we are going to classify our angles. There's also ways we're going to classify our triangles. So if we talk about our side lengths, when we have triangles, how many sides does a triangle have? That's right, there's 3 sides to a triangle. So if you have all 3 sides equal length, we use these little hash marks to mean if they're the same number of hash marks, that means it's equal length. If we have all 3 sides that are equal, it's called an equal, and each side is like a lateral, so it's equilateral triangle. And that means that all 3 sides are the same length. The other way we could have, well, instead of if all 3 were the same length, what if you had 2 that were the same length? So we're going to put 2 dash marks on this side, but only 1 on each of these. That means that 2 of the sides are congruent or equal length, and 1 side is different. And this is called an isosceles triangle. One of the sides is isolated. It's isolated. It's different than the other 2 sides. This is called an isosceles, and it's spelled I-S-O-S-C-E-L-E-S. This is an isosceles triangle. Remember, one of the sides is isolated. One of the sides is different. And the third opportunity we have here that we can see is if all 3 lengths are different. If all 3 side lengths are different, we'll put 2 there, we'll put 3 there, they're all at different scales. They're all in a different scale. So we call these scalene triangles. Scalene triangles. Awesome. Let's start measuring and go over if we can classify these triangles by their angles and by their side lengths. Awesome. 6.0C review, triangles and angles. So please track along with me as I'm reading aloud. So finger or pen on the paper. Thank you. Measure the sides of each triangle in centimeters to the nearest tenth of a centimeter. So some of us might be off a little bit. Measure the angles to the nearest degree, so as close as you can get. Record the measurements and classify the triangle based on the sides and the angles. So I want both answers there. Okay, so let's take a look at triangle number 1. Taking on triangle 1, again, I'm going to use my protractor. Make sure you don't have your triangle or your protractor backwards. It's going to be very difficult, if not impossible, to read if your protractor is backwards. So make sure you see your protractor. Always start at the end of a length, so I'm going to measure the base of my triangle here from there to there. Sometimes putting a dot is helpful. And then you want to make sure you start at 0 when you're measuring, and that this lines up, it's not like crooked, so it's as accurate as possible. So it looks like, so that's a half. Remember, I want to start at 0. I don't want to start at the end of my protractor because that's not where the measuring starts. So it looks like this is really close to 8.5, maybe a little bit more. So I'll measure that. 8.5 centimeters. Check it out one more time. It's just a little bit more than 8, but it's less than 9. I'll measure the next side. 1. Looks like that. Looks like it's exactly 8 centimeters. And we'll measure this third side, the last side. And it looks like that's about, it's a little bit more than 5.5, but we'll just say it's about 5.5 centimeters. Okay, so taking a look at this, it looks like based on my side measurements, which are 5.5 centimeters, 8 centimeters, and 8.5 centimeters, that this is going to be what type of triangle? Are they all the same, equilateral? Is one of them different and two of them the same? Isosceles? Or are all three different, so they're at a different scale, so it would be scalene? Well, it looks like all three are different, so this is definitely going to be a scalene triangle. But now I need to check out, what about the angles? So I'm going to grab my protractor, and I'm going to start with this angle right here. So I'm going to take my protractor and I'm going to line up. I'm going to line up the vertex of my angle with the hole in the center of my protractor. I'm also going to make sure that this bottom of my angle where I'm measuring lines up with that line on my protractor with the 0. Notice this is 0 and I'm measuring up this way. So that means I'm going to use my inside numbers for my protractor because that's where 0 starts with. So if I measure all the way up, it looks like this angle is going to be about at, well, this is 60. It looks like it's at about 65 degrees. Would you say it's about 65 degrees? It's more than 60, but less than 70. So we're going to say that that is about 65 degrees. Perfect. So now I'm going to move up to this angle. And again, I could have measured the angle I just measured going this way, and I would have used my outside numbers because the 0 lines up on the outside from the angle I'm starting to measure at. And again, if I look here, again, it should be 65 degrees. So I feel pretty good about that angle. So let's take a look at the next one. I'm going to line up my vertex with the center point. I'm going to make sure that this line lines up with the 0. I notice my 0 is on the outside. So I'm going to measure swoop all the way across this angle. And I notice that this ends up and again, I'm using my outside numbers, looks like it's almost at 80 degrees. Practically at 80 degrees. Maybe you're getting closer to 75 degrees. Let's see. Let's see if we line this up really nicely. Outside numbers. Remember, you're going to have to kind of go like this. Practically here, which lines up with 75 degrees. So sometimes if you're not exactly sure, make sure to remeasure. Or if you wanted to measure from the other side, to double check, make sure your zeros lined up. Now I'm using the inside numbers. And it looks like, yeah, it's definitely at 75 degrees, not at 80. So it's at 75 degrees. Cool. One last angle to measure. So again, I'm going to line up my vertex with the little hole in my protractor. I'm going to have to be very careful about lining up the zero, not just this line, but the actual zero with my base angle. And then I notice my zero's on the outside, so I'm going to go up this way. And see that my line intersects, it's 140 on this side, which corresponds with 40 on the other side. So that one is exactly 40 degrees. Perfect. So taking a look at my angles, do I have any angles that are greater than 90 degrees? If you have any angles that are greater than 90 degrees, then it's going to be obtuse. Do I have any angles that are exactly 90 degrees? Well, if you had any one angle that's exactly 90, it's going to be right. Well, I don't have any here. It looks like all of my angles are less than 90 degrees, which means that this is a very adorable little triangle. It's an acute. So we would call this triangle scalene acute. Perfect. You're going to be working with your groups. I'm going to pause the video. You're going to be working with your groups on 2, 3, and 4. And I'm going to check back with you in about 10 minutes. So please pause the video for 10 minutes and work on 2, 3, and 4. Thank you. Okay, let's go over 2, 3, and 4. Taking a look at triangle 2, I had 4 centimeters, 7.5 centimeters, 8.5 centimeters. All those sides are different lengths. They're different scale. So it's a scalene triangle. Looking at the angles, 30 degrees, 60 degrees, and 90 degrees, because we have one 90-degree angle, that's what makes this entire triangle a right triangle. If you only have one angle that measures 90 degrees, it's going to be a right triangle. Okay, let's take a look at 3. Triangle 3, notice we have side lengths 4 centimeters, 7 centimeters, and 9.5 centimeters. So I'm rounding to the nearest whole or half centimeter with my measurements to be as accurate and consistent as possible. And my angle measurements are 20 degrees, 40 degrees, and 120 degrees. Because all the different side lengths are a different scale, scalene, we notice that it's a scalene triangle. They're all different side lengths. And because one of the angles is over 90, this one angle is 120, which is more than 90, that makes this a scalene obtuse triangle. Perfect. Last triangle you had to work with, triangle 4. Notice my triangle's measurement side lengths are 6 centimeters, 6 centimeters, and 9 centimeters. My angles are 45 degrees, and 90 degrees. So taking a look, one of my side lengths is isolated. Since one of my side lengths is isolated, it's 1 is different and 2 are the same. That's what makes this an isosceles. And then because we have one angle that's 90 degrees, one angle that's 90 degrees, it's an isosceles right triangle. This is an isosceles right triangle. Please pause the video for 5 minutes to finish 5 and 6. And then I also want you to think about in your groups, what do you notice about the largest side and largest angle in your triangle? And what do you notice about the smallest side and smallest angle? So please pause the video and we'll go over our answers on video 2. Thank you for pausing the video and starting the next video in 5 minutes.